Hello students and welcome to another video on logic design. In this video, I will attempt to solve a few more theorems in Boolean algebra so that you get an idea how to tackle other theorems or expressions. You have already seen this particular slide on axioms and laws in a previous video on Boolean algebra. If you are not familiar with this slide, please go through the previous videos before watching this one. These laws and axioms will help you solve Boolean expressions in order to validate them or prove them true. Let us take a look at a theorem from your textbook, and this theorem is called as the consensus theorem or factor theorem. We will use Boolean algebra to prove this theorem, which reads as AB plus A bar C plus BC is equal to AB plus A bar C. To deal with this problem, let us first start with the LHS. In the LHS, I will introduce another term A plus A bar. I can do this since A plus A bar is equal to 1, that is the negation law, and putting it there won't change the logic value of the equation. Now I'll open out these brackets to get the following equation. I will rewrite the equation as follows. Notice that BCA is made equal to ABC and BCA bar is made equal to A bar BC. This is done using the commutative law. Also, I like arranging the variables in alphabetic order because it becomes easy to filter out common terms. Now, if you look at this equation very carefully, there are some common terms, namely AB and A bar C, which is highlighted in red and green respectively. Now, you simply take out AB and A bar C as common to get the equation as follows. This particular equation can now be filtered and be written as AB plus A bar C. Why? Because 1 plus C is actually equal to 1 and 1 plus B is also equal to 1 because of the identity law. Now you can see that we have got the RHS, and hence you have successfully proved that the LHS is equal to the RHS. Let us take a look at another theorem from your textbook. This theorem is called as the Transposition Theorem. We will use Boolean algebra to prove this theorem. AB plus A bar C is equal to A plus C dot A bar plus B. Let us start with the RHS. Open out the brackets to get the equation like this. I am going to rewrite the equation so that C A bar is A bar C and CB is written as BC. I do this because I like following the alphabetic order, and this is also allowed because of the commutative law. Observe this equation, especially the term A dot A bar. If you recollect, A dot A bar is actually 0 using a law called as the negation law. Also, since A plus 0 is equal to A by a law called as the null law, we can ignore this 0. I will rewrite the equation as follows. Now, to solve this equation, I will include a new term in the equation, A plus A bar. This can be done because A plus A bar is equal to 1 using the negation law, and also it does not change the logical value of the equation. Open out the brackets to get the following equation. Again, I will rearrange the terms to follow alphabetic order by using commutative law. Clearly, you can see that there are some terms which can be removed common, that is AB and A bar C. And using the identity law, that is 1 plus C is equal to 1 and 1 plus B is equal to 1, we get left with AB plus A bar C, which is nothing but the LHS. And this successfully proves that LHS is equal to RHS. De Morgan's laws. This famous mathematician by name Augustus De Morgan was born in Madurai, India to British parents. His father, in fact, worked for the East India Company. He formulated a pair of transformation rules which are now famously called as De Morgan's laws. The first law states that a plus b the whole bar equals a bar dot b bar. That is, the complement of a sum of variables is equal to the product of their individual variables. The second law states that a dot b the whole bar equals to a bar plus b bar. That is, the complement of a product of variables is equal to the sum of their individual variables. Both these laws can be extended to any number of variables. Let us now look at an example on how to apply De Morgan's laws. In fact, the process of application of these laws is called as De Morganization. The equation is given as a plus b bar dot c plus d bar the whole bar. In order to solve this, we are going to break the top bar using De Morgan's second law to get a plus b bar the whole bar plus c plus d bar the whole bar. Now using De Morgan's laws again, break the smaller bars and we get a bar dot b double bar plus c bar dot d double bar. Since b double bar is equal to b and d double bar is equal to d, we get the final equation as a bar dot b plus c bar dot d. Try your hand at De Morganizing the following equation. That's all for now. Boolean algebra is a very easy topic in logic design and a question paper favorite. Remember that practice makes you perfect, so check out your textbook for more solved and unsolved problems. Stay tuned to the classroom for more videos and learning material.